Hey, what's up guys? This is your sir with another video. In this video we're gonna talk about diazotization of aromatic primary amine. Okay, so let's talk about general reaction first. Okay, in this I'll take in simple primary amine and it's called as aniline. Okay, so this is basically called as aniline. Okay, and aniline is treated with diazotizing agent called as NaNO2 plus HCl, which results in a formation of HNO2. In this video I'm gonna tell you why we take NaNO2 plus HCl mixture. The purpose of taking this one is to generate HNO2. Okay, to generate HNO2, along with this NaCl is also formed. Let's see the explanation. NaNO2 is a salt of strong base and a weak acid. Sorry. Okay, yes. It's the strong base is NaOH and weak acid is HNO2, nitrous acid. Okay, and when it reacts with HCl, it forms the salt. NaNO2 reacts with HCl, then it forms HNO2. I'll tell you the purpose behind this, or the main principle behind this. This is a salt of a strong base, weak acid, and it reacts with a strong acid. Then the salt of a strong acid is formed. Salt of a strong acid is formed and weak acid is regenerated. Regenerated. And we know that reaction takes place from towards the weaker side, means a strong acid always displaces weak acid from its salt solution. Now a student asks a question, so why not take directly nitrous acid? So let me tell you very frankly, nitrous acid is not that much stable. Okay, so in situ we have to prepare. Whenever situation demands, we have to prepare nitrous acid. So this is the purpose of taking NaNO2 and HCl. Okay, and when you treated this, you will take an diazonium salt. The structure is somewhat like this. Okay, let's go for the mechanism, how the reaction works. We have to look for that. Okay, so in first step we'll see the formation of electrophile. And electrophile is nothing but nitrosonium ion. Okay, it is this particular species. Okay, let's see. We know that the structure of nitrous acid is like this, and it is a weak acid. Compared to HCl, so it accepts in H plus ion from the acid and it forms HOH, and lone pair is over here and this is double bond O. Oxygen gets a positive charge. We know that oxygen is highly electronegative atom, so the positive charge is not stable over it, so it just break this bond and releases as a water molecule. Okay, it just releases water molecule, and further we are having N double bond O positive, and this is the lone pair. Okay, plus H2O. At the same time, H2O is a good living group. Now majority of the time student thinks, why sir, it isn't like, you know what, that always this bond is broken, this particular bond is broken, why not a hydrogen electron is being taken by oxygen and this particular bond is broken? So let me tell you, compared to this like water molecule and this nitrogen, this reaction is generally covered by the funda delta G is equal to delta H minus T delta S. Okay, now it is mainly governed by the entropy. Can you see this is one molecule, and out of this one molecule we are having two molecules, so entropy in this reaction is positive. Okay, so this total del T delta S value becomes more negative and it leads to more negative value of delta G, hence reaction moves in a forward direction. Okay, that is the reaction. And if you just remove H plus from here, it will be again a backward reaction. So in order to move it forward, this particular step happens, and that is the entropy of the reaction increases. So now we have got our electrophile. So now we'll proceed further. Okay, so in second step, our aromatic amine, that is this NH. Okay, there is a lone pair associated with nitrogen, which it donates to nitrosonium ion and double bond O. Its positive charge gets vanished. Okay, there is no need to show lone pair, but if we are showing, it's okay. And nitrogen gets a positive charge. As we know that nitrogen is highly electronegative atom, so it does not stable in case of plus form. So there is a step take place called as intermolecular proton exchange, and we have this particular species. The hydrogen of nitrogen is being transferred to oxygen, and oxygen gets a positive charge. Okay, again the problem with oxygen is it is highly electronegative atom, so positive charge is not stable, so this bond pair is taken by the oxygen, and in next step we are having NH and positive OH. Okay, nitrogen is again having a lone pair, so it donates to the neighboring nitrogen so that it should be stable. Okay, and again nitrogen gets a positive charge. I'll just show it into the next step. Okay, and in next step is somewhat like this. So this is N double bond N O H, and nitrogen again gets a positive charge. Okay, now this is the hydrogen. Once again the step takes place, which is called as intramolecular proton exchange. The hydrogen, this particular hydrogen is being transferred to the oxygen. Okay, and then we are having N double bond N O H and H. Oxygen gets a positive charge since it donates its lone pair. Okay, and here again nitrogen is having a lone pair, so it just donates its lone pair to the neighboring nitrogen so that its octet gets completed. Okay, sorry, there's a mistake. Wait, actually this oxygen is having a positive charge. I just made a mistake. Oxygen is having a positive charge, so what oxygen does, it just takes the electron of nitrogen, and being a good living group, it is released from the system. And further we are having N double bond N positive. Okay, here I'll write minus H2O. Okay, this nitrogen is having a lone pair, so it donates lone pair to the nitrogen, and finally we are getting triple bond N positive. Okay, and as the system is having acidic medium, so chloride ion is there. System is having acidic medium, so there is a chloride ion which gets attached to this one. Okay, so this is formation of our diazonium chloride. Okay, now I would like to tell you a very important concept related to diazotization, that is, during the reaction temperature is a very important criteria. It should be maintained between 0 to 5 degrees Celsius, because in diazonium salt this N triple bond N positive is a very good living group, very good living group. So it may leave the reaction mixture as a nitrogen gas, and finally we are having this positive charge species. Okay, so care must be taken for preparation of diazonium salt. The temperature should be around 0 to 5 degrees Celsius. Okay, and this positive charge, it may either get combined with the chloride ion, but if this system is having water molecule, if hydrolysis is being done, so it may result in a formation of a phenol as well. Okay, so I hope you understood the concept thoroughly. Okay, and don't forget to share and subscribe the channel. Thanks a lot for watching.